My name is William Zhu, and this is my Intro to Materials project. The concept that I will be talking about will be mechanical exfoliation. Graphene has a unique structure of carbon atoms arranged in a 2D honeycomb lattice, which each atom using an sp2 hybridization and with an atom thickness of about 0.345 nanometers. Because of its unique bonding structure, it gives itself high strength, electricity, and heat conduction. We often harness its potential by using composites. There are three ways to make graphene. The one shown now is by a type of mechanical exfoliation where using tape and relying on the weak intermolecular forces or van der Waals forces within graphite to peel thin layers off, breaking the weak forces and eventually leaving you with a thin layer of graphene. This Scotch tape method is to isolate graphene was first discovered by physicists Andrei Geim and Konstantin Novoselov in 2004, which later earned a Nobel Prize in 2010. This next part demonstrated is another kind of mechanical exfoliation and is known as shear exfoliation. This can be done with a regular blender, but it is strongly advised that afterwards to not use the blender ever again and throw it away. This is done by using an surfactant or a surface active agent, which is the blue dish soap that I had in the little bowl earlier. In this version, we mix the dish soap, water, and graphite together, and we use the shear forces created by the blender and the help of the dish soap and water to break the van der Waals forces between the layers of graphite and potentially forming little graphene layers. While that is blending, I can talk about the other ways to create graphene. There's another popular way to make graphene and is used and scaled up for graphene production right now in the industries. It uses a ultrasonic bath and is basically the same as the blender, but many times better. This is also a kind of mechanical exfoliation. It uses ultrasound waves, creating shear forces to break graphite into graphene sheets. I did not use this method because it was expensive. In the following clip, I will show you the slurry that was made using the blender method. There is no way of knowing if mechanical exfoliation occurred or if graphene is even created. However, it is very likely that there is little graphene particles within the slurry that would not be possible to be seen. Mechanical exfoliation in material science is mainly used to create atomically thin particles or sheets to the point where material can be classified as 2D. It heavily relies on the breaking of van der Waals forces, and there are many types of mechanical exfoliation. There are those that are shown in the video, being tape and shear exfoliation. There is also the mentioned ultrasonic exfoliation. Some other types not mentioned are ball milling and liquid phase exfoliation. Mechanical exfoliation is an important concept in material science, especially for the future. These developed 2D materials will usually have very unique properties, like the before mentioned graphene. Although it is commercially available, it's still not widely used due to the ability to scale up production at a manageable price to a point where it could be widely used. These unique properties using graphene as an example can include flexibility and bendability while maintaining high durability. Graphene is also high in thermal conductivity, allowing for greater thermal management in everyday objects like phones, iPads, graphics cards, and sportswear. There is actually already sportswear that use graphene. However, that comes at a very steep price. There are many difficulties in using mechanical exfoliation that could include things like low yield, low purity, the before mentioned challenge in large scale production while keeping costs low. There's also a challenge in control production, since due to the scale of production, when scaled up, there could be damages on the material that would be tough to make out since it would mostly be on an atomic level. That is why there is other methods being explored for these materials, like chemical exfoliation and chemical vapor deposition. Thank you. Are there any questions?